Hey everyone, welcome to the Chapter 8 review. This is technically Unit 7, so just put it in the title. I'm going to go ahead and go over all the even numbers, and you're responsible for doing all the odd numbers. So let's get started. You're going to classify each equation as direct variation, inverse variation, or neither. So remember, direct variation is y equals a times x, with a being your constant of variation. Inverse is y equals a divided by x, a still being that constant of variation. Alright, and neither just doesn't look like either one, okay? So looking at number 2, just make sure it's in y equals form. I can minus x over, and it says negative y equals negative x plus 13. Flip the signs, positive y equals positive x minus 13. It's still going to be neither because it's adding a negative 13 while it's subtracting it. Yeah, so that's it. Okay, that's all there is to that one. Number 4, well, if you're trying to classify something as direct, then you need to figure out the a. So if direct is y equals a times x, then a will equal y divided by x. And if something's inverse, well then if y equals a divided by x, then a is going to equal y times x or x times y. And so you just do that over and over again to see if you get the same number. So I have some big numbers here, so I'm just going to try dividing them first. So I'll do 132 over 12, see what that equals. I'll do 198 over 18, see what that equals. And I'll just continue that pattern, just making sure they're all the same. Right now, 132 over 12 is 11, 198 over 18 is 11, so it's probably direct. It's a good idea just to check all the values. It's not like it's difficult or difficult math or like time-consuming math. There might be, if there's one value in there that doesn't make 11 when you divide it, then it's going to be neither, or I guess it could be inverse, but I really doubt it. So I just need to type these in and verify that these are all 11, and they are. So this is definitely a direct variation problem. Okay, so given that it's a direct variation problem, a is 11, and remember I just wrote the formula for direct right there, so I'm going to just circle it. This is direct, this is inverse. Okay, so if you need to write the equation y equals a times x, a is 11, so I'll just say y equals 11 times x. Alright, and that's it for that one. Okay, moving on. For the following functions, determine the domain, range, vertical asymptote, and horizontal asymptote. Okay, so remember the domain is where it's restricted on the x. And so look at the bottom and set that equal to 0. So x equals negative 2. So that means I have a vertical asymptote, because x equals 2 is a line that would go straight up and down. So vertical asymptote is at x equals negative 2, and that means my domain is all real numbers where x can't equal negative 2. Alright? That horizontal asymptote, y equals negative 4, that'll make a flat line. And so that means you just look at that outside number, and that's how I got the negative 4. And that means the range is all real numbers where y can't equal negative 4. And that's it for that one. Okay, let's move on to number 8. Number 8, the form looks a little bit different. There is no number on the outside, so it's like your vertical asymptote or horizontal. I'm getting my vocabulary mixed up. The horizontal asymptote will not be the outside number since there is no outside number. But you're going to start it off by taking the bottom and setting it equal to 0, just like we did on the last one. And so I will add 8 to the other side. And I have 4x equals 8, so that means I'll divide by 4. And I'll get x equals 2, okay? That tells me my vertical asymptote. Yes, x equals 2 will make a vertical line. Just think about it. If a line is passing through the x-axis, it's going to go straight up and down. All right, so yeah, it gets confusing, I know, but just think about what kind of line that it will make. So that means my domain can't equal 2. All right. Now, the vertical horizontal asymptote is you just take the coefficients that are by the x's, and so there's an understood 1 as a coefficient by that x on top. So my horizontal asymptote is going to be 1 over 4, okay? You don't write the x's. Y equals 1 over 4, and so my range will then be all real numbers where y cannot equal 1 over 4. And that's it for number 8. Let's move on to number 10. Okay, so number 10, I'm dividing two rational expressions. And so remember, if it's not written as a fraction, throw it over 1. And then if you're dividing, it's the same thing as flipping the second fraction and writing it as a multiplication problem. So I'm going to do it times 1 over x squared minus 6x plus 9. All right. So the key with these is to just factor and simplify. And so what are my factors of negative 36 that add to negative 5? And then what are my factors of 9 that add to negative 6? So I have, with the negative 36, I know that's 9 times 4, and if I make the 9 negative, that'll add for negative 5 and multiply for negative 36. And then if I do 9 and 6, well, negative 3 plus negative 3 is negative 6, and times together is positive 9. So I'm going to rewrite this as x minus 9 times x plus 4 over x plus 2 times 1 over x minus 3 squared, or if you want, just write x minus 3 twice. Remember, before you cancel anything out, you need to write where x can't equal. And so looking at the bottom, x can't equal negative 2 or positive 3. That being said, let's cancel stuff out that can cancel, and it really doesn't look like anything is going to cancel. So that just means my final answer is going to be x minus 9 times x plus 4 times 1, so it's just going to be those two, over x plus 2 times x minus 3, and then to save space, I'm just going to write x minus 3 squared since it's the same thing. And so that's the final answer. Yeah, that's it. Let's move on to number 12. Okay, so number 12, I'm now subtracting two fractions, and so I'm going to factor where I can. I see that this is 2x minus 2. I can rewrite that as 2 times x minus 1. All right, and then this is a quadratic function, or expression, I should say. What are my factors of 3 that add to negative 4? 3 times 1 is 3, but they don't add to negative 4. So let's make them both negative. Negative 3 plus negative 1 is negative 4, and times for positive 3. So I'm going to write this as x minus 3, x minus 1. All right, so let's just rewrite this real quick. Okay, so I rewrote everything, but I did change this. This has two negatives, so I factored out the negative, and so that's going to be 2x plus 1. So that's what I did right here. It's always easier to factor out the negative, in my opinion. Now, they're not ready to add or subtract unless the denominators are exactly the same. So with this fraction here, I need to multiply a 2 over a 2, all right, because this one has a 2. Now, this one has an x minus 3 that this one doesn't have, so I'm going to add an x minus 3 over an x minus 3, okay? So what we need to do is distribute everything and then simplify. So when we distribute everything, this is going to turn into a plus. So that's really one of the reasons why I like factoring out a negative, is because now I have a plus. And so now I just need to do 2 times 2x plus 1. So that's going to be 4x plus 2. And then I need to do x times x, so that's x squared. X times negative 3, negative 3x. 2 times x, that's 2x. And then 2 times negative 3, that's negative 6. All that is over 2 times x minus 1 times x minus 3. And at this point, we can identify what x can't equal. Well, no, I'll save that for maybe the next step. Let's add all our like terms together. I have negative 3x, 2x, 4x. So that's going to combine for 3x. And I have just an x squared there. So x squared plus 3x. And then I have minus 6 plus 2, so that's negative 4. And that's 2 times x minus 1 times x minus 3. All right, so what are my factors of negative 4 that add to 3? Well, that's going to be negative 3 and negative 1. Nope, it's not going to be negative 3 and negative 1. Negative 4, positive 4, oh man. So positive 4 plus negative 1 is 3. Positive 4 times negative 1 is negative 4. There we go. So the top is now going to say x plus 4, x minus 1 over 2 times x minus 1, x minus 3. So now I see something's going to cancel, but I need to write what x can't equal, and that's going to be positive 1 and positive 3 right here and here. All right, so you want to do that before you cancel stuff out so you don't forget to leave something out. But the final answer will be x plus 4 over 2 times x minus 3. All right, where x can equal 1 or 3. Okay, so that's that one. Let's move on to number 14. So here I have two rational expressions that equal to each other, or two rationals that equal to each other. So that means you're gonna have to cross multiply and divide. Before I do that, the instructions say check for any extraneous solutions. An extraneous solution is, what x can't equal. So when we were doing these other ones and we identified that x can't equal, negative 2 or 3, those would be extraneous solutions. So if we ever work something out and we get something that x can't equal, it might be a no solution type problem, or it's just that's not part of the answer. But looking at this bottom right there, there's an x on the bottom, so x can't equal negative 2. So it's just something to keep in mind for when we work it out. But right now, we're just going to cross multiply like normal. 2 times x squared minus 3 equals x plus 2 times x minus 3. And now I just need to distribute. So 2x squared minus 6 equals x squared minus 3x plus 2x minus 6. This can combine for just a negative x minus 6, let's say, or x squared. So I'm just bringing this down, 2x squared minus 6. Let's get everything to one side. So 2x squared is bigger than x squared, so I'm just going to minus everything over here, minus x squared. I'm going to add x, and then I'll add 6, add 6. Okay, so that everything cancels there, so it'll equal 0. 2x squared minus x squared is x squared. X added to nothing is x, and then negative 6 plus 6 is 0, so x squared plus x equals 0. So I have a greatest common factor of an x. Let's divide it by an x. X squared divided by x is x, and x divided by x is 1. So this turns into x times x plus 1 equals 0. So your two answers here are x equals 0. If I plug that in on the outside, that will make it go to 0. Or if I plugged in a negative 1 on the inside, that will make it go to 0. So I got 0 and negative 1 for my two answers, and my extraneous solution was negative 2, so there are no like extraneous solutions or whatever. I guess you could say my asymptote or discontinuity is probably the better term. But yeah, that's it for number 14. Let's move on to number 16. So number 16, let's identify that discontinuity or the asymptote, however you want to call it, and that's x can't equal negative 6. All right? So we're going to factor the top. What are my factors of 36 that add up to 12? And that's negative 6 and negative 6. I mean positive 6 and positive 6. What am I saying? Because they both multiply for positive 36, and positive 6 adds for positive 12. So I'm going to write x plus 6 times x plus 6, or you could write x plus 6 squared over x plus 6, doesn't matter, equals 0. The nice thing about writing it separately is that you can clearly see that they cancel just one time. So you're left with x plus 6 equals 0. So if we were writing the expression, we'd be done. But since it equals 0, you need to solve it. So solving it is really simple. Just minus 6 to the other side, and x equals negative 6. Now, we just said, though, that x can't equal negative 6. So since that's the only solution, and we can't equal that, then we must conclude that there is no solution. All right? But we wouldn't have known that without doing all this work, okay? But that's going to wrap it up for the review. Thanks for watching. Good luck on the test. Bye.